Hi everyone, and welcome today to looking at similar figures. We're in our topic of congruence and similarity, and today we're going to learn how to identify similar figures. Last time we were looking at what makes two things similar, and we learned last time that if we have two things that are the same shape but not necessarily the same size, then they are said to be similar. Okay? So same shape but not same size is what we mean by a similar figure. Okay. What are some other things that need to be in place for two figures to be similar? Well, there's two main things with similar figures. Firstly, all the matching angles are equal in similar figures, and also the matching side lengths are actually in the same ratio. Okay. So that's really important for you to kind of remember that all the matching angles are equal and all the matching side lengths are in the same ratio. So those things are really important. And that's basically what makes two figures similar, which means this: they're the same shape but not the same size. To prove that two figures are similar, you only need to prove one of the above two things. Okay, so you don't have to show them all, just one of the two things. Okay. So in this first question, let's look at some examples together now. It says state whether the following pairs of figures are similar, giving reasons. Okay, so we're going to say, are these similar, yes or no, and why? And the reasons are going to be either matching angles are equal or matching side lengths are in the same ratio. Okay, so let's have a look at these together. Now I've got this triangle here, and if I look at the angles in the same position, I can see a 100 here and a 100 here. This is 8 and this is 4, so it appears to be, this bigger one appears to be twice the length of the smaller one. I've got a 30-degree angle and some unknown angle, but I know here if this is 130, then it takes 50 degrees to make it to a 180. Okay, so I'm going to say that I actually do think these two triangles are similar. So I'm going to say that these two are similar. And now I'm going to say why. Okay. Well, basically, AC over PR is the same as BC over QR, which is equal to 2. Okay, and because the two sides are in the same ratio, it implies the third must be. Therefore, all three sides, in fact, I need to be writing better than that, all three matching sides are in the same ratio. Okay, so that's really important. And because I've shown that all three sides are in the same ratio, I've proved that they're similar. So I gave some reasons. Okay, I could have also said that all the angles were equal and listed them, but I chose to use the sides. So let's have a look at what we would have done then. So I'm finished the question here now. Okay, that's enough. But I want to show you the alternative way now. So if I was going to use the angles, here's what I'd have to do. I'd have to go angle C equals to angle R equals 30 degrees, and that's given in the picture, so I'm going to write given, otherwise I have to write my rule. I can also say that angle B equals angle Q, which is 100 degrees, and that's also given. And therefore, angle A must be equal to angle P, which equals 50 degrees. Okay, and I can write the angle sum of a triangle equals 180, but I can't fit that in. But then I basically say, since all matching angles are equal, the triangles are similar. Okay, so that's important. Let's have a look at the next one. Are these similar? Yes or no? So I've got this point here, 100. I've got 30 and 50. So perhaps this is has been transformed and reduced down. But I would say that yes, these are in fact similar. Okay, and I'm going to prove it using the angles because I have no sides. So I'm going to say this, angle B equals to angle P equals to 100 degrees, given angle C equals to angle R equals to 50 degrees. Now you'll notice that this triangle has been, the orientation has changed, hasn't it? It's been flipped. So this A here is really where the Q is, okay? So make sure you be careful of that. And I can say that angle A is equal to angle Q, which equals to 30 degrees, and that's given. And I'm going to say since all three matching angles are equal, the triangles are similar. Okay, so I'm giving a reason and I'm writing a statement, and that's pretty much what geometry is all about, giving a reason, writing a statement. Question C, now these aren't triangles, but the concept is the same, so I'll let you have a look at that. You can either use the sides or the angles to prove it, okay? So you have a go at that one yourself and bring it to class. Write a summary of what you learned and any questions you have, and make up a question that you find really interesting or challenging. Bring your work to class with you, bring your booklet, and we will go through this together next lesson. Today we've learned about identifying similar figures, and the two main things that if you can show that matching angles in both figures are equal or matching side lengths are in the same ratio, then those figures are similar. See you soon.